All right. And what I'll try to do this week is get on here and open this up. I mean, obviously 9:20, that's my start time for opening up the Zoom room. But I'm going to put a warm up that I think you guys should do every day this week. Just kind of like review everything, get back in the swing. But I'm going to go over it right away. I don't have time to like delay. So let's jump right into this. I just have to turn my laptop around. All right. So just remember that for when it comes to logs, okay, it's the exponent. If you have log base n, or no, I don't want n. Log base a of something equal to a number, this n, that's the exponent that goes on a that will give you x, okay? So this is what you should be thinking. So what's the exponent we put on 2? That's going to give me 16.
4.
4. Okay, good. That was meant to be like a very comfortable start. Okay, now look at this part B. What exponent goes on 125? That's going to give me 1/5. Anybody have it? Yeah, good, Sydney. So I know that 5 to the third, I know 5 to the third is 125. Okay, so then to get 1/5, I would have to take the cube root and I'd have to flip it to get it 1 over. So it's negative 1/3. Okay, good. Who's got C? How about log of 0.001? Oh, Sydney's on fire. Okay, so this is, remember, if there's no number written, that means it's log base 10, right? So this is 10 to what power is going to give me 0.001, but that's 1 over 1,000. So it's -3. Any questions on any of those? All right, this one here, when your bases are the same, the base and then the exponent is the log, and that base is 5. It's going to be just what's right in here. Yes, square root of 3. Okay. What's the exponent I would put on square root of 11 to get 11?
2.
Yep, we'd square it. If you square square root of 11, you get 11. And then this one was meant to be a little more challenging than all the rest. How can I get from 27 to 9? I would have to cube root it, right? If I cube root 27, that's 3. So cube root of 27 is 3, and then you square it is 2/3. So this one should have been 2/3. Okay, any questions on those? All of those, every single type is fair game for your quiz on Friday. It should have been a bunch of them in the hand-in homework. Okay, all right, number 2, when you go to solve this log, the first thing you have to do is isolate the log. Okay, so you should have subtracted 1, and you get 4 of log base 7. 3x minus 2 is 8, and then divide by 4. And so you get log base 7 of 3x minus 2 is equal to 2. Okay, then we have to use that definition. Okay, so 2 is the exponent that goes on my base, which is 7. That gives me what's inside, 3x minus 2. This to this power will give me this. You cannot solve it while it's in the log form. You have to use the definition to get rid of the log, okay? Then we just solve this. So 49 equals 3x minus 2, add 2. And I get 51 equals 3x. When you divide by 3, x is 17. And there you go. Any questions on that? All right, last but not least, the other thing we talked about was domain, and I picked just a basic one to start us off with today. The domain restriction is that whatever goes inside your log has to be what? Greater than 0, okay? Always, whatever your inputs are, that which goes in it, whatever x's go in, you can never get log of 0 or log of a negative number, okay? Now that 1/3 has no bearing on what's going, like that's just a constant. So I threw that in there. It doesn't matter. It's not going to change what you're putting in your function as long as this part stays positive. So this is going to be 7. If I add x to both sides, I get 7 greater than x, which is the same thing as saying x is less than 7. And in interval notation is -infinity to 7, not included. Okay. Any questions? All right. So that was basically last week. What we're going to do today is, this is 9.4. There's 2 things I want to talk. Well, we're going to do a lot of work with properties of logs. So there's some pretty cool stuff that we can manipulate when it comes to logs. So here's the first one. It is called the product rule. Okay. And it says, okay, so for all of these, I'm going to use x, y, and base a, and these are all positive numbers. But I don't want to have to write that every time, okay? So here we go. Say you have log base a of x times y. 2 things multiplied together in the input. You can rewrite this as log base a of x plus log base a of y. So I can actually break those apart into addition. Here's my second property. It's called the quotient rule. Okay, if I have log base a, now this time it's a quotient, so that's division. Quotient means division. So x divided by y, I can break this up, log base a of x minus log base a of y. And then the third one is called the power rule. And this one is pretty sweet. We're going to use this one a lot. Log base a of x to the y. Let's use, yeah, we'll just use y. That's fine. I can take that exponent on x and bring it down. We just kind of like parachute it down front. Come on. My screen just kind of, it's taking a little break, guys. Apparently I had too much turkey. Let me write. All right, so what you're going to write is y times log base a of x. There we go. I think I can get it now. Y times log base a of x. Okay. So basically, and it can be like this too. Okay. You just kind of like bring this exponent down. Okay, excuse me guys for a minute. Okay, sorry about that. So the other thing about these properties that you need to know is that they go both ways. So if you have two logs that have the same base in its addition, you can also bring them together under multiplication. You can bring them together under division, and you can move the constant in the front back up as an exponent. So let's play around with some of these. Let's do some examples. And you will have to memorize these. You need to know these. Okay, so let's do some examples. Find the exact value of each. So here's A, log base 2 of 8 times 32. Okay, so we see in there times. Times means product, okay? And then that means we're going to use our product rule. And I'm going to take this and rewrite it as log base 2 of 8 plus log base 2 of 32. And that's just going to break this down so it's a little bit easier to figure out. So 2 to what power is 8? 3. Plus 2 to what power is 32? That one's 5. And then some people already put in the chat that's 8. So, you know, could you have figured this out by multiplying? Yeah, but you would have had to figure out that 2 to the 8th power is whatever 8 times 32 is. Okay, usually we don't know them that high up. So this helps us break it down and do in smaller, more manageable steps. All right, so here's another one. You guys, all right, let's try this. Log base 2 of 16 over 32. Okay, this is a quotient. So I can rewrite this as log base 2 of 16 minus log base 2 of 32. Yeah, so this is going to be 2 to the 4th power is 16 minus 2 to the 5th power is 32. It's -1. I want to point something out though, because this is going to come up a lot. There is more than one way to do this. I wanted to use that quotient rule, but we could have also just simplified the fractions. So look at this. Log base 2 of 16 over 32 is the same as log base 2 of 1/2, right? 16 over 32 is 1/2. That's all it is. Well, 2 to what power will give you 1/2? -1. Okay. So there's going to be many times different approaches to these properties. And probably for students, sometimes it's frustrating because you guys always want to just know what to do without having to think about it. But it's also kind of cool because you can come up with different ways to do things, and there, as long as you follow properties or definitions, it'll be good. All right, let's try some that are not numbers now. So write each of the following as either a sum, product, or difference. Okay, so here's A. Log base A of x to the 7th. Okay, so this is a power. I have a power on my input, so I can bring it down and do 7 times log base A of x. Okay, so I've written it as a product. So this is just practicing using these properties. That's all we're doing here. Let's do log base A of PQ. Let's make this more interesting. Let's do PQ squared. Just the Q is squared, okay? Just the Q. Now, that looks like it's an exponent, like the one above it, but since the exponent is not on both the P and the Q, you can't bring it down yet, okay? First, we have to handle this product. So we're going to rewrite this as log base A of P plus log base A of Q squared. So first, break it up as into the addition. And then we can take care of that exponent on the Q. I don't want to leave it there because that's not completely written as a sum product or difference. So I want log base A of P plus, now I'm going to bring the 2 down front, and it's 2 log base A of Q. And that would be completely like deconstructed, I guess. That's not like a technical math term, but that's what I feel like you're doing. You're just kind of trying to use the properties to write it as a sum product or difference. Okay. All right, you guys try this one. Log base A of P to the third over, oh, expand and condense. I like that. That's good. Z. And I'll tell you what, let's make it interesting. Let's make this the square root of Z. Let's see what you guys got. Log base A of P to the third divided by square root of Z. Does that method apply to? Yes, it goes for numbers. We're going to do some more of those examples with numbers in about 10 minutes. we gotta practice expanding and condensing. Okay, your first step should have been to write this as a difference. Okay. You guys cool with that? Then I'm just going to repeat kind of like what we just did. This 3 comes out front, so it's 3 log base of 3 of P, 3P, CP3, C3PO. Now, oh yeah, thank you for the A. Thank you. Don't forget your base. Now the thing is that square root of Z, remember, square root can be written as Z to the 1/2. So we can write this as log base A of Z to the 1/2. And you guys, just FYI, Z to the 1/2 is the same as Z to the 1/2. Okay, same thing. And then we have an extra little step of bringing that exponent down. So to completely expand this, this is 3 log base A of P minus 1/2 log base A of Z. And that would be the final one. Did anybody get that? Catch that with the root? I'd be super impressed. All right, let's do, I'm gonna do a hard one. Here we go. Skipping ahead, like 3 examples. Just because we have a lot to do. And unless you are totally lost, and you can tell me in a private chat, I'm going to keep pushing. Okay, so log base A of, now let's do x squared y over 4 times the cube root of 7. That's like everything. Okay. I've got everything in there. So what's the first step? What do you guys think we should take care of? The multiplication, the division, or the exponent? What comes first, do you think, in expanding this out? Let's do a little guess here. Even if you don't say it out loud, make a prediction. Okay.
Division.
How about the, oh, go ahead, Mohammed.
I said division.
Division, that's right. So what comes first? Because this has got lots of packed full of vitamins, this one is. Okay, I'm sorry, I'm so corny. There's division, there is multiplication, and then we have exponents. Okay, so yes, division comes first. That's the first way to break this apart. So we're going to take log base A of x squared y minus log base A of 4 cube root of 7. Now, within each of these, I have products. Okay, so we're going to break apart. We're going to do products first. So this is the order. I actually wrote it in the order without even thinking. Must be my mathematician self. All right, so this is going to be log base A of x squared plus log base A of y. Now here's where you got to be a little bit careful. Subtraction is tricky. I have to make sure we subtract everything when we break this other one apart. So this is log base A of 4 plus log base A of cube root of 7. Okay, remember that subtraction, once you break that second one into 2 things, that subtraction is going to distribute. Okay, now I can do some stuff at the same time here. Let's bring this exponent down. So this is 2 log base A of x. And that's it. There's nothing else I can do with that one. There's no other properties to be used. This one, there's nothing to do but rewrite it because the properties have already been used up. Now I'm going to distribute here. This is minus log base A of 4, and there's nothing else I can do here because I don't know anything about A. Maybe if I knew A was 2 or something, we could do something, but we don't. And this is going to be minus, there is something I can do here. Square root of 7, or I'm sorry, cube root of 7 is 7 to the 1/3. So I'll just make sure I write that step so that it's not confusing. And then I do have to write this one more time. So 2 times log base A of x plus log base A of y minus log base A of 4 minus 1/3 log base A of 7. And that is completely expanded. That's a lot of stuff. That's everything. All right, so now let's go in the opposite direction. Let's condense. Express each of the following as a single, I'm going to put condensed because I like that word, logarithm. So let's start here. Okay. if I have log base 3 of x plus log base 3 of y cubed. Okay. I have addition. So what does that mean? I can bring those two together as? Is it going to be a product, a quotient, or a power?
A product?
A product. Yes. Multiplication. So this is going to be log base 3. And notice the bases do have to be the same. And this is x times y to the third. And that's the single log. That's all we can do. It's really just one move there. Any questions so far? All right, let's do this one. 1/3 log base 4 of x squared plus 2 log base 4 of y to the 5th. I'm not messing around, guys. We gotta, yeah, okay, good. We're gonna get to the fun stuff really soon. All right, so now, just like just how we did the exponents last before. So when we're condensing, it's kind of the opposite. You want to do exponents first. And then multiplication, division is kind of like, it shouldn't matter, but we'll see, okay? All right, so I'm going to bring my exponents. Let me just rewrite this. 1/3 log base 4 x squared. It's 2 log base 4 of y to the 5th. And I'm going to bring these up as exponents, okay? So this is going to become log base 4 of x squared to the 1/3 power plus log base 4 of y to the 5th squared. Now, when you have a power to a power, what do we do with those powers? What can I do with that 2 and that 1/3?
Multiply.
Yeah, multiply. So this is going to become, you know what? I'll put it inside, be 2/3 plus log base 4 of y to the 10th. Now I have that addition. And like we just saw, when you have the addition with the same base, I can bring these together as x to the 2/3 times y to the 10th. And I'm okay if you leave it like that. You can make it a cube root and rewrite it, but it just looks messy. Any questions? All right, one more. 3 log base of x squared, log base 10. Okay, I'm not forgetting the base, that is base 10. 1/5 log base 10 of x to the 10th. You guys go ahead, try this one. I'll give you like a minute. See if you can condense that into one log. Okay, when you parachute the exponents up, you should get x to the 6 and x squared. And since it is subtraction, we're going to bring those together as a quotient. And you always go, the fraction goes in the order that you see it. So the first minus the second means the same as like top over bottom. Now, here's the thing, guys. This simplifies. I saw people put this, but what's x to the 6th over x squared? X to the 4th. So you can do that. That's okay. Any questions? All right. Now, we're going to use these properties and use them with numbers, and also I'm going to give you approximations for things, okay? So here's an example. Use the approximate values, and I do not, repeat, do not use a calculator for this. You have to figure out how to do this without a calculator. So I'm going to tell you that log base 4 of 7, which is not a whole number, because 4 to some power is not 7, is approximately 0.7. And log base 7 of 20 is approximately 1.5. So I'm giving you that. So we're going to use those values to find the following. So here's A. Log base 7 of 4 over 7. Okay. Now here's the thing. You cannot just plug these in. Like you can't, you have to get things expanded first. I can only put, this is not the same as saying like, this is not the same as saying log base 7 of 4 over log base 7 of 7. Okay, that's wrong. So you can't do that. You can't just plug in 0.7. We have to use our properties. So use the properties. I want to say that in red. Use the properties to expand first. Okay. Now, what you do notice is if I look at this and do this as a quotient, some nice stuff happens. So once we expand it out using our quotient property, then I do have some stuff I know. Okay, I have log base 7 of 4 by itself. So this I can say is 0.7. Okay, once I have that by itself and isolated, then I can make my substitution and say that's 0.7. Now, what about log base 7 of 7? I'm not given that, but I do know something about that. I didn't put this one in the warm-up. 7 to what power equals 7?
1.
1. So this is just 1. So that's a really powerful, like helpful fact to keep in mind when you guys do these, that log base A of A, that's just going to be 1. Okay. So if you can break these up and you get that, that's a nice little bonus. Okay. So then once I have this, then I just know this is going to be negative 0.3. Because 1 minus 0.7 is 0.3, but since it's smaller minus bigger, it's negative. No, it's not the same.
So if it's not the same, why did you put 0.7? Because at first, at the top right, you wrote log 4 of 7.
I'm sorry. Thank you. Did I have it written down? This was supposed to be this. Sorry. I wrote down the wrong thing. I switched those. Thank you, Cornelius. That makes a big difference. So the given was supposed to be log base 7 of 4, not log base 4 of 7. Sorry about that. Okay, any questions? All right, let's do another one. let's say you have log base 7 of 16. Oh, Amarian, thank you. So when I look at what I'm given, again, these two things. This is all I can use. So this is what I'm saying. You can't just use a calculator. I have to use these facts. So here's 2 that I'm given. Here's a generic one. But we can also use our properties. See how I have log base 7 of 4? Well, can't we rewrite this using our power rule? This is log base 7 of 4 squared. 16 is really 4 squared. Now that's still not quite log base 7 of 4. I have to do one more thing. What can we do? What property would help us here?
You can parachute the...
Yes, the power rule, okay? Put the 2 in front. So we're gonna put the 2 times, this is gonna be 2 times log base 7 of 4. Now, once again, I have this by itself. You can't just plug in 0.7 and square it. That's not the same thing. It has to be log base 7 of 4. So this is going to be 2 times 0.7, which is 0.14. Okay, any questions? So you're looking to use the properties so that you can break them apart and use the information you're given. All right, here's another one. Oh, maybe I did multiply that wrong. You're right. I'm sorry, it's 1.4. Too much pumpkin pie, guys. Actually, what I made was pumpkin cookies. Not too big on pumpkin pie. And it had chocolate and pecans in it. They were good. All right, log base 7 of 25. All right, so again, 25 is not log base 7 of 4, and it's not log base 7 of 20. This one's going to take a little work. So one thing I can do, sometimes you just kind of like, okay, let me start somewhere. I know that this is 5 squared. And so just recall, I'm looking for using log base 7 of 4 or log base 7 of 20 or log base 7 of 7. That's stuff I know stuff about those. Okay. So when I do this, I can bring this down, and this is 2 times log base 7 of 5. Now 5 is not any of this other stuff, but can I use something with 20 and 4 or 7 to get 5? Is there a way to go from those to 5? What operation could we use? Oh, you could use the 20, then use the product rule. Oh, I could. Yeah. Okay. The problem is, how do I write 5? How do I write? I can't write 5. I can't make 5 20. That's the thing. But what I can do is write 5 as 20 divided by 4. So 4 times 5 is 20, but I want to rewrite 5 using 4, and 20. So it's the same as 20 divided by 4. This will give me 2 times log base 7. Now I can, this is a quotient, I'm almost out of time here, of 20 minus log base 7 of 4. But be careful, this is all multiplied by 2. Now I can use everything I know. This was 1.5. Log base 7 of 4 was 0.7. And then this is times 2. So this is 2 times 0.8, which is 1.6. So you can see, like, in part B, when we just had 16, you can write that as 4 squared. That was pretty straightforward. Sometimes you have to do a little more work. Yeah, but the problem is, Marianne, if I do log base 7 of 4 times 5, that doesn't equal, this does not equal 2 times log base 7 of 5. Like, those aren't the same things. I can't, like, I got to make sure that whatever my input is, whatever that number is in the parentheses, that you don't change it. You can rewrite it, but you cannot change it. Okay, questions? We will do more examples of these tomorrow. You'll get these in workshop, and they're coming up on your homework. And these types of problems do tend to be on the final exam. So you got to know how to do these. All right, guys, have a good day. I'll see you tomorrow.
All right, thank you.
Bye-bye. I'm going to stop.
Bye.
Thank you.